Good. This is an example. Again on kinematics. A track covers 75 meters in 5 seconds while slowing down to a final velocity of 2.5. Now, what was the original velocity of the track and what is its acceleration? And the third question is, how long does it take the track to come to rest? Let's see. Let's take out the givens. Okay, let's take out the givens. Now, the givens, the first, okay, givens. Now, a track covers 75 meters in 5 seconds. So, the displacement or the distance, okay. Now, let's see. The displacement is equal to 75 meters, or the distance is equal to 75 meters. And the time required, or the time the track took to cover this distance is 5 seconds. 5 seconds. And the track has been decelerating, okay, slowing down, and the final velocity, the final speed or velocity the track reached was 2.5 meter per second. Then the requirements are now here the requirements, okay, here the required, okay, the requires A, original velocity, VI, okay, original velocity. B, okay, B, it's acceleration, and C, okay, total time, T, total time, okay, when VF is equal to 0. VF is equal to 0. Now let's see the solution part. Here we have the solution, okay, for A. So you should remember one of the fundamental formulas or equations in kinematics. Now, from this general formula, from S is equal to VAV over T, okay, VAV over T, we can have this, okay, again, displacement is equal to VF plus VI divided by 2 multiplied by T. Then VF is given, T is given, and VI is, and again displacement is given. Ti is the only unknown in this. So from this, we can say that VF plus VI is equal to 2y of S, 2 times displacement divided by T. Again, this implies VI is equal to 2 times displacement divided by T minus VF. This is equal to 2 times displacement is 75 meters, and the time required here is, the time taken here is 5 seconds, and VI minus VF is minus 2.5 meter per second. Now here, by 5, 15 times, by 5, 1 times. Now 2 times 15 is 30, this is meter per second, minus 2.5 meter per second. 2.5 meter per second. 28, 27. Okay? This is equal to VI, the original velocity of the motion or the track has been 27.5 meter per second. Okay? 27.5 meter per second. This is to mean a truck, okay, traveling at 27.5 meter per second travels 75 meter in 5 seconds. 5 seconds, okay? This is the initial velocity of, or the original velocity of the track. Okay, let's see part B. Now in B, okay, we are supposed to find the acceleration. We know that acceleration is changing v over changing t. Now, the point at which the track starts, okay, decelerating can be taken as 0 second, okay? That is where the time has started counting. Now, acceleration is equal to v final minus v initial divided by t, wherein changing t is tf minus tr. This is equal to the final velocity of the track is 2.5 meter per second minus the original velocity was found to be 27.5 meter per second, and the time taken for this motion is 5 seconds. Now 2.5 minus 27.5 is 0.55 is cancelled out. Then this is 20. This is 20. Okay. 5 is taken. 25 meter per second divided by 5 second. But this is negative. Oh, yeah, this is negative. So this is going to be negative, okay, 5 meter per second square. Okay. What does that mean? What does acceleration of negative 5 meter per second mean? Okay. Now, here we have a vague matter. Now, the acceleration is negative 5 meter per second square. Good. Now, this is to mean the acceleration, the velocity is being decreasing at a rate of 5 meter in every second. So, if you are asked to find the acceleration as it's shown here, you should put negative 5 meter per second square. This is to mean now in this motion there is deceleration, decrease in the velocity of the motion. So the acceleration is negative 5 meter per second square. If you are supposed to write in other word, now you have to write deceleration is equal to 5 meter per second square. Deceleration is the negative of acceleration. Good. Now the third one is the total time. Now the third one is the total time of the motion. That means the total time in which the track come to rest. Now here, just to remind the givens. Now the initial velocity of the motion was found to be 27.5 meter per second. The final velocity of the motion is given as 2.5 meter per second, and the time. This is the final velocity. Okay, now the final velocity as it comes to rest is simply 0 meter per second. Now we know that the acceleration is constant. The object is decelerating at a rate of this. Okay. So, what is the time from this? What is the time taken for a 27.5 meter per second moving track to reach to a velocity of 0 meter per second? where it decelerates at a rate of 5 meters per second. Now we know that acceleration is equal to change in v over change in t. Now the total time is, okay, counting the time begins at a point where the track starts decelerating, okay, decelerating. So now this is equal to vf minus vi divided by tf minus ti. Okay, this is acceleration. Now in our case, ti is again taken as 0 because we start where we are supposed to find the total time. Okay, the total time the track decelerates, okay, decelerates for the total time taken by the track to come to the point of 0 meter per second. So this is equal to vf is now 0 minus vi is 27.5 meter per second divided by tf minus 0. This is equal to negative 5 meter per second square. Now this implies now tf can be taken here. Tf is equal to 0 minus this is negative 27.5 meter per second divided by negative 5 meter per second square. Now the negatives can be cancelled out. Okay, the negatives can be cancelled out. Then 27.5. Now this is 5 times 25. Then 25 point. Okay, to now 5.5. Now here we have meter per second, again meter per second square. Now this is equal to 5.5 meter per second times second square divided by meter. Now meter can be cancelled out, okay, second. Then this is 5.5 second. Now TF or time is equal to 5.5 second. So a track moving at a speed of 27.5 meter come to rest after 5.5 seconds. So this is the total time required for the track to come to rest. Okay, we'll have one more example. Well, this is example 4 on kinematics, on motion with constant acceleration. A jet plane lands with a speed of 110 meters per second and it's slowed down at a rate of 6 meters per second square. As it comes to rest, A, how long does it take the plane to come to rest? And B, is that safe to land this jet on a runway of 1 kilometer? Now, B is to mean how far does the plane move until it comes to rest. Okay, B is about distance, and A is about time. Let's identify the givens and the required. Now here we have givens. Okay, givens. Here we have the requirements. Now initial speed of, okay, as it lands, the speed of the plane is 110 meter per second, 110 meter per second, and it's slowed down. Okay, it's slowed down at a rate of this. So the acceleration here is because it's slowing, it's negative 6 meter per second square. Okay, and the final velocity here is, the final speed here is vf is equal to 0 meter per second. 0 meter per second. Then the requirements are how long does it take the plane to come to rest? Now the time required, okay, A, the time required, T, as VF as the plane come to rest, or for the plane to come to rest. B says, question B, is that safe to land this jet on a runway of 1 kilometer? We can't say that it's safe or not without knowing how far the plane travels, okay? As its velocity decreases from VI to V, let's say VI 110 to 0 meter per second. So, to say safe or not, okay, we are supposed to find the distance. This is B is to mean on the other hand, how far, meaning is that less than 1 kilometer, okay? If the distance the plane travels in its decelerating motion is less than 1 kilometer, then this is safe, okay, safe. If less than or equal to, okay, if this is greater than 1 kilometer, this is unsafe, okay, unsafe. So that here we are supposed to find the distance the plane travels before it comes to rest. Let's see the solution. Now, solution. T. Here we have initial velocity, final velocity, and acceleration. Acceleration is negative 6 meters per second squared. We know that from our previous discussions. Acceleration is equal to change in speed divided by change in t. Okay? Now, acceleration is equal to Vf minus Vi divided by t. Because we can assume that as the plane touches the landing or the runway, the time here is, okay, 0. So change in t, which is Tf minus Ti, is equal to t, because this is taken as 0. As it touches the ground, the time can be counted as 0. Then the acceleration, which is deceleration, 6 meters per second squared, is equal to the Vf is 0 minus initial speed is 110 meters per second divided by t. Then t, this implies that t is equal to 0 minus 110 is 110, okay, 110 meters per second divided by negative 6 meters per second squared. Oh, this is negative, so the negatives can be cancelled out, okay? The negatives can be cancelled out. Then this is equal to now 110 divided by 6 meters per second times second squared divided by meter. Now meter can be cancelled out by meter. Here we have second square, one of them can be cancelled out. This is equal to 110 divided by 6, 110 divided by 6. 110 divided by 6 is equal to 18.33. Now this is 18.33 second is the time required, okay? The time required for the plane, the jet, to come to rest. Let's see how far it travels, okay? How far it travels. Now this part. Now B, S, okay? S, how far it travels. Now we know that this is S, okay? S is equal to VAV times T. Average speed times T can be the velocity, the distance. And the runway is 1 kilometer. Okay, the runway is 1 kilometer. This is equal to Vf plus Vi divided by 2 multiplied by the time taken. Now Vf is 0 meter per second plus the initial speed was 110 meter per second divided by 2 multiplied by the total time, okay, which was found to be 80.33 seconds. Okay, 0 plus 110 is 110, okay, 110 meter per second divided by 2 multiplied by 18, okay, 0.33 second. Now this is 55, okay, 55. Now second is cancelled out. It's 55 meter times 18.33, okay, meter. Let's see the product. 18.33 times 55 is equal to, this is equal to 1000, okay, 1008, okay, 1008.15 meter. Then what is your suggestion? Is that safe or unsafe? Now, the runway, okay, here, the runway is only 1 kilometer. Here we have. Suppose this red color runway, okay? Suppose this is the runway, which is only 1 kilometer long, okay? This is 1 kilometer long. This is 1 kilometer long. Now, the aeroplane, the jet landed here, okay? The jet landed here. Let's see, I'm poor at drawing, okay? The jet landed here. But according to our data, the jet will stop. This is 1 kilometer. Okay, the jet will stop some 8.15 meter. Okay, the jet will stop 8.5 meter away from out of the runway. Okay, the jet will decelerate and stop here in the danger zone. Okay, the jet is going to be here. Okay, the jet finally is supposed to, okay, according to, okay, the jet will be here. So the jet is out of our runway, out of runway. This is greater than 1 kilometer. 1 kilometer. So that this is not safe, okay, not safe to land, okay, not safe to land on a 1 kilometer runway. So do not forget to like, okay, share and subscribe on AHATube. AHATube, your partner in physics, mathematics and engineering courses. Like us, share us, subscribe on our tube. Thank you for watching. We'll see you on other videos.